Okay, this problem, when the absolute value is less than a number, you have to set it up differently. You are first going to do what you did. No, it's okay. You are first going to set it up like you did. Y'all can go ahead and talk. Where you just copy it down, okay? Remember that absolute value is distance. So if you think about it, what they're saying is that this distance, whatever was inside, is less than 3 away from the starting point. Okay, so if your starting point was that orange blob I drew there, that means you're going to be either this far away, or this far away, or somewhere less. The distance is less than 3 away. So you want to kind of show that on a graph by just showing, you're going to have 2 endpoints and then, something in between. So what we have to do is figure out how do we write that with inequalities. Well, I didn't mean to put that absolute value there. I should just copy it this way. X plus 2 is less than or equal to 3. How would we describe that? Doesn't it mean like if this were like the spot, it would be in between the positive and the negative of the 3, right? So what we can do,
what does it really look like? Does it say in that book?
We could actually make a sandwich inequality out of this, because we're saying the distance is less than 3 away from the starting point. So we can say, okay, it's less than 3, and it's in between -3 and 3. So that's how we do it. We take this number and we write it down without the absolute value. That's what this part kind of is. And then we just put duplicate that inequality sign here and put the negative of the number there. And then we would solve it like this. These become like those that you did up higher. You're just now setting them up yourself. We're going to get x by itself, so subtract 2 from all 3 parts. -3 minus 2 is -5. Use a calculator if you're messing your negatives up, because you don't want to miss it because you subtracted. And then 3 minus 2 is 1. So if I'm going to graph that, let me actually draw the real graph. This was a kind of a thinking graph over here. Okay, that's what thinking graph. So I know I need to go down to a little bit past -1. Okay. So my boundary points are -5 and 1. Let me circle them. It's going to be everything in between. Do we color in those dots? Yes, because look, both of these have the equal sign. That means we count the boundary value. So this is how we would do 19 here. Number 23 is another one where we're trying to say the whole distance here, whatever's in here, is less than 16 away from our starting point. So if you remember what we do from the last problem, we copy it down without the absolute value signs. We kind of do that on both different types of situations. But because we want it less than 16 away, we're going to sandwich this distance between the positive and the negative of that number. So once we get that done, that's the hard part, is just figuring out how to write it. Now we solve for x. We're going to add 6 to all sides. And that would be -10 is less than or equal to 5x, because these would add to 0 and go away. And that would be 22. And now we're solving for x. And remember, things don't always turn out pretty in real life. So to get x by itself, we're going to divide everything by 5. And we're going to end up with -2 is less than or equal to 1 over 1x is just x. And then we got this ugly fraction. If we're drawing this, let's see, -3, -2, -1, 0, 1, 2, 3, 4, 5. You divide 22 by 5, you get like 4.4. So we're going to put that end point like somewhere like here, okay? Just because, and again, you're going to have to excuse the big blop. I can't write with a fine point with the stylus. The other end point is down here at -2. And the reason I'm making solid dots is, look, we have all these little equal signs under our inequalities, and we shade in between. And again, we've made a sandwich inequality, and this happens when the absolute value is less than a number. The distance is less than a number. 29 is a trick question. This book likes trick questions. An absolute value has to give back a positive number. Can you have a positive number be less than a negative number? That never happens, does it? I mean, I can't do that. I mean, anytime you see an absolute value on one side and a negative on the other, that's a clue that there are no solutions. That's just nonsense. A distance is positive. You can't have something be less than a negative distance because a negative distance doesn't exist. So that's kind of a trick question. They love to give you those to see if you're understanding the overall idea.